In 1-7, we're going to be working with midpoint and distance in the coordinate plane. So first of all, let's talk about what I mean by in the coordinate plane, right? The coordinate plane is basically what you've been thinking of as a sheet of graph paper. It's got your x-axis, so go ahead and label that, and your y-axis, and we plot points in the form x comma y, which you should be used to, where x is left or right and y is up or down, which we'll talk about a little bit more. But we're going to be talking about, if you look at this segment AB on the graph, we're going to be talking about what are the coordinates in the midpoint, and in this lesson we're going to talk about how long it is. What is the distance between those 2 points? And we find both of those with formulas. So first we'll talk about the midpoint formula. Definitely note card worthy. So we've got 2 points that we're going to just generically call our first x, or x sub 1, our first y, y sub 1, and x sub 2, y sub 2. Those are our 2 points. Now that might seem kind of confusing because you might say, well, I don't get what those points are. They might be the point where x1 is 2, y1 is 5, and maybe x2 is -1, and y2 is, let's say, I don't know, 9. All right, so they can be anything, but once you know them, you can find the midpoint between them. Because really, all you do is you average the x's to get between the x's, and you average the y's to get between the y's. Well, you should know how to get an average. If you had 2 test scores, one that was a 70 and one that was a 90, and I said, what was your average? You should know that you add them up and divide by 2. Well, that's what we're going to do with our coordinates. We're going to take our x's, our first coordinates, add them up and divide by 2, or also known as averaging them. We're going to take our y coordinates and do the same thing. So really, we just need to know how to add and how to divide, and we have to remember that our answer is a point in the coordinate plane. So let's go do a little practice. So this is, what are the coordinates of point A? Coordinates are always in parentheses with a comma with the x first. So the x coordinate of point A is how far to the right it is. It is 7 to the right, so that would be a 7. And the y coordinate is 3, because we're 3 up. If it was 3 down, it'd be -3. I'm going to assume that you know that, and that I just sort of insulted your intelligence, right? Because we've been plotting points at Hope for quite a while. So similarly, point B is at -5, because it's 5 to the left, and +5 because it's 5 up. All right, so now it says use the midpoint formula above to find the coordinates of M. M is going to be the midpoint of segment AB. Well, I'm going to go do exactly what my formula says. First of all, I'm going to realize that it's a point. It gets locked and loaded in a pair of brackets or parentheses, if you want to consider it that. And I grab my first coordinates, my x's, which are up there in red. I add them and I divide by 2, also known as averaging them. And then I do the same thing with the second coordinates, the y's. I add and I divide by 2. And then I just arithmetically simplify that. So the top of this one would be 2. 2 divided by 2 is 1. When I add these, I get 8. 8 divided by 2 is 4. So my midpoint is the point 1, 4. I'm going to go plot that in yellow. I'm going to go 1 to the right because it was positive, and I'm going to go 4 up because it's also positive. I'm going to label it M, and I'm going to say that looks amazing. It so looks like I just landed right in the middle of segment AB. So now we're going to go practice it. We'll remove the graph, but just basically use the formula. So I'd pause the video if you're doing this on a video and try this one on your own. So what is my midpoint? We usually call that M. It's always in some parentheses with a comma. We're going to add those x's up, -1 and a -5. We're going to average them. We're going to add those y's up, those second coordinates, and we're going to average them. We're going to do our arithmetic. I'd have a -6 Negative 6 divided by 2 is a negative 3. We're going to add up our y's. 7 plus negative 2 would take us down to 5. 5 over 2 we can write as 5 over 2. It does not reduce. Or if you prefer to write 2.5 or 2.5, that's fine. And that's all we do to find the midpoint. We add the x's, divide by 2, add the y's, divide by 2. Sometimes a more troublesome thing to do, though, is to find a missing endpoint. So it's kind of like if I told you one of the endpoints, the midpoint, and asked you for the other endpoint. That's what we're going to be doing here. All right, so I'm going to first teach you how you would see it in a textbook, and then I'm going to teach you my method, which is called the method of common sense. In a textbook, you would use the formula that I just gave you to find the midpoint. So what you would do is you would go like this. To find the midpoint, I'm supposed to add the x's and divide by 2, but I don't know what this first one is, so I'm just going to call it x. So I'd say my first x is 7, my second one is unknown, and I'm going to divide by 2, but I know what I got. I know I must have had a 1. And then what you would do, squiggle, 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 is the same thing with the y's. I know there's a y of 3. I don't know this missing y over here, but I know that when I average them, I got a y value of 4. So basically working backwards, and then you'd use algebra to solve this. So to undo division by 2, we'd multiply both sides by 2. And then to undo the addition of 7, we would subtract 7 from both sides. So the x-coordinate right here of b would have been a negative 5. And you could check it by working forward. Average them. 7 plus negative 5 is 2. Divide by 2, and I get a 1. So it's very checkable. This isn't how I would do it, but if this makes a lot of sense to you, now I'm going to stop here and see what I wrote. Where did that 8 come from? To undo division by 2, we multiply by 2. So I'm doubling both sides to algebraically attack that y variable. I'll subtract 3 from both sides and get a 5. Excuse me. Good, there we go. So negative 5 would have been the coordinates of missing point B. Now I'm going to challenge you to think of this as more common sense. So watch what I'm going to do. I'm going to take my first endpoint that I know. Beneath it, I'm going to put the midpoint that I know. Beneath that, I'm going to put my missing one. And what I do is I use common sense. If I walk 2 steps to the right to get to the middle of something, won't I go 2 more to the right to get to the other side? Think about that. If I went 3 steps up to get to the middle, let's call this M right here, won't I go 3 steps in that same direction to get to the other endpoint? So I call this walk and keep on walking. Here's what I mean by that. To get from 7 back to 1 on a number line, I'd go back 6 steps. So if I go back 6 more steps to get to the other end, I'd be at negative 5. Bam. If I go from 3 to 4, I go up 1 step on a number line, so I'll continue going up 1. I call it walk and keep on walking. Notice I arrived at that same endpoint, both algebraically and with LaRude's common sense. So I challenge you to pause the video and pick the method of your choice. Mine is common sense, so that's how I'm going to do it, to find the missing endpoint. So now that you're back, here's what I do with my common sense method. I start at point A. I'm going to walk to point M, the middle. I'm going to keep on walking in the same direction to walk me to the other endpoint. So let's start walking. Negative 1 to 12 would be going, 11 would be going up 12. So I'm going to write a little plus 12 there. Going up 12 got me to the middle. So I'm going to go up 12 more to get me to the end. Kind of think of like an escalator. If you go up 10 stairs and you're in the middle of the escalator, you'd go up 10 more to get to the other end. So I'd be at 23. Walk and keep on walking. I have to go down 11 stairs to get from 3 to negative 8. So to get to the other end, I have to go down 11 more for a negative 19. The other method would give you that same answer for the coordinates of point B. So that's it for our midpoint. Okay, it has a nice formula, easy to use, easy peasy, mac and cheesy. Now our distance, sorry for the clanging. Now our distance formula. So now we're going to be talking not about what's in the middle of this segment, but how long it is. So again, I have 2 points that I can't see. They're somewhere sitting on the coordinate plane. And I'm going to use a formula to find the distance. And first of all, I'm just going to give you just the explicit formula right in your face, and then we'll talk about how to use it, how you can maybe make it easier. The actual formula says you take the square root of what you get when you subtract those x's. Then you're going to subtract those y's. And then you're going to square it. This is what the actual formula says. If you were to Google, what is the distance formula? Try it. This is what it'll say. Now to make it a little cleaner, sometimes it's going to be easiest for you to think about just how far apart are the x's. We'll talk about that when we get to an example. So you don't not even really think about subtracting, but think about how far apart they are. Same thing here. How far apart are they? But we'll talk again about doing it explicitly and doing it with a little common sense. So first of all, without a graph, I'm going to do this one exactly as the formula says first, because some people like to do that. The formula says to get the distance between those, remember we talked about the distance between is the 2 endpoints without any symbols over it. So that would be the distance or the length of the segment QK. We take a square root, that's just in the formula. We look at our x's. The formula says to take the second x, subtract the first x. Now here you have to be careful because subtraction's in the formula, but my x is a negative 1. And then you square, and then you go and do add, and then you do the same thing with those y's. You take the second y, negative 1, you subtract the first y, and you square it. And then you just have to be very careful with your arithmetic. This would be 5 plus 1, subtracting the negative. So that'll be a 6 squared under there. This will be negative 1 plus 3 because of the 2 negatives, so a 2 squared. So with my arithmetic, I end up with the square root of 36 plus 4, which is the square root of 40. And then in your homework, you'll be going to a calculator and rounding that to the nearest tenth. So I'm just going to take 1 second and hop on my calculator. So give me a minute, I have to load it here. And I'm just going to go take the square root of 40, and on whatever calculator you have, find your square root button, and I get a 6.3245, which to the nearest tenth we're going to call 6.3. Later in the year we'll talk about simplifying that root, but for now our goal is merely to use the distance formula. Now I also talked to you about, maybe you think about just how far apart the x's are and how far apart the y's are. Then you can avoid all the subtracting of a negative, and here you have a negative, subtracting another negative. That kind of lends itself to some sign errors. So the other thing you could do if you want, when you subtract numbers, you're really just getting how far apart they are. So just grab these x's and in your head say, how far apart are those on a number line? They're 6 apart. Think of temperature. How far apart are these on a number line? If you were just to graph, like how far apart are -3 and -1? Then remember we count the spaces, they're 2 apart. So you avoid all the negatives if you just ask yourself, how far apart are the x's? How far apart are the y's? And then we're right back up to 36, but we're at 40. So kind of consider that method if you like it. Either way is fine. So let's go take a look up here when we have the graph. Then I would definitely do the how far apart. And this is where I'm going to see if some of you remember your middle school. Yeah, and again, you can do it either way, guys. If you want to use the formula and go x2 minus x1 squared, just be careful. The other way to do it is to head across on the x-axis and say how far apart are those. Count the spaces, 1, 2, 3, 4, 5. And then head down on the y-axis and ask yourself how far apart are they. Now, you can even just with the numbers, how far apart are they? They're 7, or you can count the blocks. You've got a 5 by 7 right triangle. That's where the square root part comes in from the formula. For some of those of you who are like kind of mathematically in tune or you really like math, I think you guys know that a squared plus b squared equals c squared, right? Maybe. If you do remember, that's great, because to undo squaring, you square root. So that's where the square root comes in our formula. So really, that would just be this if I have a graph. Now, suppose you're like, nope, I don't even remember the Pythagorean theorem. I don't get it. I don't like shortcuts. Here's what you would do. You would go grab your formula. You would go x2 minus x1. You would square it. 2 minus a negative 3 is 5, and you would square it. You get that exact same number under there. You would then do negative 3 minus 4. You'd subtract the y's. y2 minus y1. You'd square it. You get negative 7 in parentheses squared. See, so that's why, sometimes kids think negative 7 squared is negative 49. Not if that negative 7 is in parentheses like that. So got to be a little careful, but we'd still get a 25 plus a 49 under the root, which is exactly what I got with my guess. I like to call those smart cuts, not shortcuts. So again, if I was presented with a graph and it asked me how far that was, I'd go 5 squared plus 7 squared equals the hypotenuse squared, and I need to square root it. So I would just go how far apart are the x's, how far apart are the y's, square root it. Now let's see if you pause the video, see if you remember how to get the midpoint of that. You might need to go back and look at your formula for how we get the midpoint. Okay, now that you're back, how do we get the midpoint? Remember, it's a point, so these are important. A lot of people, sometimes kids will write like a midpoint as a fraction. Like if they find the middle of the x's is 5 and the middle of the y's is 2, they'll write 5 over 2. And I'm like, no. It's a point. It's coordinates. X coordinate, Y coordinate. All right, so what does our formula say? It says we add the x's, those first coordinates, negative 3 and 2, we add them. And then we average them. Then we add the y's, 4 and a negative 3, and we average or divide by 2. We do our arithmetic carefully with a negative 1 there, so I'd have a negative a half, and a positive 1 here. And then I'm just going to go again in yellow, go see if that looks good. What do I mean? I'm going to plot what I found to be the midpoint, a half to the left and a half up. And does that look like it's in the middle of that blue line segment? And it really does, so that looks amazing. So again, just to recap, we have two formulas. The midpoint formula finds the middle point of two endpoints by adding the x's and dividing by 2 to get the first coordinate of the midpoint, adding the y's and dividing by 2 to get the second coordinate of the midpoint. The distance formula, as it's stated, says we take second x minus first x and square it. But if you like to maybe make it a little more user-friendly, really this is just how far apart they are. So really, if you're like, I don't want to subtract negatives, you just go and you say, how far apart are these two numbers? 6. And you square that 6. And then you do the same with the y's. y2 minus y1 if you want to physically subtract and square, or you just ask yourself, how far apart are my y's? Awesome. So your homework is Delta Math 1.7, and there is a supplement that goes with it, but if you were absent and you don't have a printer, because it is attached on the slide, but if you don't have a printer, you just go ahead and do that on a separate sheet of paper, show your work. So you're going to show me whatever you're doing to find your midpoints or endpoints, and whatever you're doing to find your distance. And if you are using the shorter method, I will accept it. I just need to see it. So I'm going to just do, I want to talk about that just a little bit. So suppose, sorry, I'm trying to get some. So those of you who think you're going to do the distance formula the shorter way, if Delta Math gives you these 2 points and you are asked to find the distance, what I do need to see on your sheet of work, your Delta Math supplement, is a root. I need to see you asking yourself how far apart are these 2 numbers, and I square it. Be careful with how far apart these are. They're not 6 apart. So that's where you have to be kind of careful. Make sure you understand it. Think of temperature. How far apart is 1 below and 5 below? They are 4 apart on a number line. I do need to see that, and then I need to see this, and then I need to see this, and then you can go ahead and round to the 10th. So I do need to see a little bit of work, even if you're using, I guess, that Smart Cut or that shortcut. Have a good one. Peace out.